In order to better understand the relationships among displacement, velocity, and acceleration, a car's motion will be examined as it travels along a straight stretch of highway. In contrast to the static picture given by numbers and equations, the motion will be studied using graphical analysis. The motion is comprised of different periods of acceleration and constant velocity, with each period lasting 5 seconds. Initially, the car accelerates uniformly from rest for a 5-second period. A constant velocity of 40 kilometers per hour is then maintained for the next 5-second period. The car experiences a deceleration and slows to a stop. For 5 seconds, the car remains at rest and then accelerates in the backward direction. The car attains a velocity of 80 kilometers per hour, which is maintained for the time interval. Finally, the car decelerates and comes to rest at a position beyond its starting point. If we look at a graph of displacement versus time for this same motion, the curve has the shape of a parabola during the acceleration period. During constant velocity, the position increases linearly with time. As the car decelerates, the slope gradually decreases. With the car at rest, its position from the origin does not change and the curve remains flat. When the car accelerates in the reverse direction, the curve takes on an increasingly negative slope. As the car travels past its starting point, it takes on a negative displacement. Looking at a graph of velocity versus time, the initial acceleration period produces a straight line with a positive slope. Upon attaining a constant velocity, the slope becomes 0. As the car decelerates, the slope becomes negative. With the car at rest, the velocity holds at 0. Acceleration in the reverse direction causes the velocity to become increasingly negative. Notice that the steeper the slope, the greater the acceleration. As the car comes to rest, the curve returns to 0. The graph of acceleration versus time takes on a very different appearance. Because the acceleration is uniform, the curve is a straight horizontal line. During periods of constant velocity, the acceleration remains at 0. Note that a negative acceleration does not always indicate that the car is slowing down. If the car has a negative velocity and a negative acceleration, it is increasing in speed. With the car moving with a negative velocity, a positive acceleration causes the car to slow down and come to rest. Comparing the three graphs side by side, the relationships among displacement, velocity, and acceleration can be examined. The slope of the position versus time graph gives velocity, while the slope of the velocity versus time graph gives acceleration.